Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a closer look at integers in C++. And although this topic is not the most interesting, and we're going to get on to more interesting stuff soon, it's important to know. So you don't have to memorize everything that I show you here, but it's good if you at least see it and just play with it a little bit, because it will stand you in good stead for the future. So I kind of want to run this past you. We've already seen that you can type stuff like int value equals 777 or whatever, and you can do cout value and endler, and if we run this program, then it's going to output 777. Now there are limits to how big an integer you can fit into this value, and that's because we're only allocating a certain amount of the computer's memory here. So the question is, like, how big an integer can you actually put in there, and what happens if you put one in that's too big? Let's put a really big number in here. Let's just make something up like this. That's not going to fit. So let's run this program, and we can see that the number we've got out is basically nonsense. It bears no relation to the number that we tried to put in, because we're trying to put too big a number into too little memory. And we've also got a warning in Eclipse here, overflow in implicit constant conversion. So I guess this is a constant, we're trying to convert it to an int, and it's just not going to go. So I'll change it back to something sensible. So how do you know, like, what value is too big to put in an int? Well, we can explore this a bit further in two ways. One thing we can do is here below the include iostream statement, type hash and include limits. And if this doesn't work for your compiler, you might have to do something slightly different, like it might be limits.h or something like that. And if that is the case, well, I'm sorry, but you might have to Google limits for your particular compiler, but I think this will work on hopefully most. So type include limits, and that's got to go below this iostream include and before this using namespace standard. And you can then do stuff like this, cout int underscore max endler. Get rid of that stray bracket there, and let's run this, and that will show you the maximum value that you can store in an integer, which is this. So let's put in here max int value. And there's also like I need another kind of chevron thing here, insertion operator. There's also a minimum value that you can store in an int. So let's put that in, and that's int min. So if we run this, we can see the minimum and maximum values that we can store in an int. And interestingly, notice that they're not the same. One's ending in 48 here, and the maximum value is ending in 47. So that it's not just one's just not positive and the other's negative. They're actually slightly different values off by one. And I think we'll go into the reason for that in a video or two down the line, because it's worth knowing. But you have to bear in mind that you can't fit all values into this int. And if you want to know what else is in, so this int max is like a constant that's stored in this file that we've included in our program here. We'll talk about that more later. But if you want to know what other values you can use in there, go to a browser, and if you search for limits.h, then you can easily find a reference to this that will show you. So we're using like int min and int max, but there are others here that you can also use. So what if you want a bigger integer? Well, you can change int by typing long. You can say long int. Let's call this L value equals, and some huge value that would not fit in an integer, and let's do cout and L value and endler, and let's see if that works. So if we run this now, so we build it and run it, and yes, these values match. If we chose an int here, I don't think they would match. Let's try it, because we'd be overflowing the amount that you can store in an int. So this is not the same as this, but if you use long, then it works. Now there's also a short int, let's call it s value, and you can fit quite small values in this. I'm not sure exactly what. Well, if we look at this file here, limits.h, we've got short max here. So this is the maximum value that you can fit in a short int. So let's go back to Eclipse, and we should be able to fit that in there. And let's just do a cout on that. I'm going to copy this one and put s value, and we'll compile it. Project build to get rid of that warning, and let's just run it. I could have just hit the run button actually. So yeah, that works. So most of the time you can just use like int and you don't really have to worry. But if you've got a really big number, you have to worry. And sometimes you want to save memory if you've got like a whole load of ints, and then you want to use a short value, or there might be some other reason why you want to use it. Another thing you can do here is you can use the size of operator to find out how much memory these types actually use. So we could say here size cout and size of int, let's say, and then I'm going to type size of, and this is technically an operator, like this is an operator. I guess equals is an operator. Never really thought about it, to be honest. Plus is certainly an operator. This is also an operator, although it's got multiple characters in it. It's not just one symbol. But we call these things operators. They kind of operate on data somehow. And this one requires 2 brackets like that, or that's how you most often use it. And then we type int in there. Or you could also type a variable name in there, like value or s value or whatever. Let's try this though, and la. And if we run this, it's going to say size of int 4. What's that for? Well, it's 4 bytes, or in other words, it's 4 times 8 bits, which of course is 32 bits. So the maximum value you can fit in an int is going to be roughly, not quite exactly for reasons that we will get into, 2 to the power of 32. It's going to be in that region. Or actually a little bit less than that, probably. I don't know. Okay, yeah, so probably half as much as that, come to think of it, because basically we need 1 bit to represent whether it's signed or unsigned, it's negative or positive, but we will talk about that more in the future. So basically, yeah, there's 4 bytes allocated here for an integer, and we could do this, a similar sort of thing with, let's try it with short int, and let's type here short int and see how many bytes are allocated for that. So we'll run this, and we see that the short int is just 2 bytes. So the maximum number that you could represent in this would actually be 2 times 8. Well, 2 times 8 is 16, and because we need 1 bit for the sign, it's going to be 2 to the power of 15, I suppose. If I'm losing you here, don't worry, I'm almost losing myself. But it's just important to know that there are sizes to these types, and you can't, sometimes you need a different size type, is the basic gist here. You also can have, for example, you can use signed and unsigned with these as well. Like I can type unsigned int, let's call it u value equals, and then it can only be positive, it can't be negative, because we could put a negative value here. This is a signed int, meaning we can have negative or positive values in it. That's the default. So the default is a signed int. But if you type unsigned in front of it, then you can only have positive values in. And that means you can store a bigger number in it, because you don't need to use 1 bit internally to represent a negative or positive sign. So sometimes those are useful as well. Let's just output that. It's not going to do anything very interesting, but let's just run it. So with the signed int here at the top, we've successfully represented a negative value. You can't have a negative value in an unsigned int, you're going to get gobbledygook. That's the whole point of it. So that's not matching this. So if it's unsigned, it can only be positive, but you can fit a bit more into it. So sometimes that's useful. And a lot of compilers let you type just long instead of long int, like that. In fact, for all I know, they all do. So often you see just long or just short by itself. So yeah, we've covered integer types. We've looked at limits. We've looked at the limits.h file here. This is actually on your hard drive. There's probably a file called limits.h that we're bringing in with this kind of include symbol, but don't worry about that. We've looked at size of. So it's, even if you just watch this video, it's better than nothing, because you're gonna kind of come to understand these different types as we carry on programming stuff in this course. But if you can be bothered, it's definitely really good if you just practice declaring long and short ints, signed and unsigned ints. Try putting values into them. See what happens if you put a value in that's too big for the type. Try using size of to get information about the type, and maybe Google limits.h and just have a look at what's in there. And that's good for the moment. So this will feel probably like a lot of information, but the take-home message here is really just that we've got long ints, ordinary ints, short ints, and they can also be signed and unsigned. So you often need to pick the appropriate type for your particular program, but most often you just use int. So practice that if you can be bothered. And in the next tutorial, we're going to look at some more types, or actually I might get into the details of exactly why the negative value of an int, maximum negative value, is not the same but negative as the maximum positive value, if you see what I mean. And and as always, I'd say if it kind of goes over your head, don't worry, because we're going to get on to more practical stuff very shortly, so do keep watching. So that's it for this video, and until next time.